Consider the pattern below. So we can see pattern 1, 2, 3 and 4. We have pattern number and number of dots. So pattern 1 has 1 dot. Pattern 2 has 3 dots. Pattern 3 has 6 dots. Pattern 4 has 10 dots. So this has gone up by 2, then by 3, then by 4. So it seems sensible. The next one would be 5, then 6, then 7. So this is going to be 15, 21, and 28. And if we look at the second difference, all of those are going to be 1. So we have a constant second difference. So when we want to determine a formula for d in terms of n, we can say that d is going to be of the form an squared plus bn plus c. Obviously we could use quadratic regression as we showed on the calculator in the last example, but let's do this one manually. Our difference is 1. If we divide that by 2, that gives me that a is a half, or 0.5. So what I have is d is 0.5 n squared plus bn plus c. Now let's use this value here. So what we're going to use is that d equals 3 when n equals 2, and that gives me 3 is 0.5 times 2 squared plus 2b plus c. So 3 is going to be 2 squared is 4, half that is 2, plus 2b plus c, which gives me that 2b plus c is equal to 1. Now let's call that equation 1. Let's use this one here as well. We just need to use 2 others, and the fact that n is even here makes it a nice one to use. So d is equal to 10 when n is equal to 4. So 10 is equal to 0.5 times 4 squared plus 4b plus c. So 4 squared is 16, half that, so 10 is equal to 8. Add 4b, add c, giving me 4b plus c is equal to 2. Call that equation 2. And here we have simultaneous equations. So 4b plus c is equal to 2. 2b plus c is equal to 1. Subtract and we get 2b is equal to 1. So b is 0.5. If we substitute that back in to say here, 2 times 0.5 is 1, so 1 plus c equals 1 gives us c is 0. Substitute back to here, and we have that d is 0.5 n squared plus 0.5 n